Hello, good afternoon everyone. Good afternoon everyone. I welcome all of you to the most comprehensive exam preparation app, that is BYJU'S app on YouTube channel. I welcome everyone. All of you please join fast. Today's topic is our pile foundation. Let us join together. I hope all of you are doing good and staying safe. So those who have joined, I will just request, please do not forget to share and like the session. Hello Aman. Okay, now let us start. This is my small introduction. As you know, hello Chaitu. Please do not forget to share and like, isn't it? And these are the sessions. Actually, tomorrow I'm going to conduct a session at 3 p.m. So tomorrow on 16th November 3 p.m. I will be taking class for railway engineering, that is geometric design, which is very important for GATE perspective, right? And after that on 18th and 28th, Ankit sir will be taking classes for construction material and management. This is my Telegram channel. You can join me. That is civil by Md Ansari Sir, and whatever the doubt you have, you can ask me. These are the star faculty of your BYJU'S Prep Civil Department, and these are the courses running on, that is Vision Gate 2022, Rank Up Gate for the practice session, and Vision 2023. This is one of the special for those who are aspiring the, as those who are aspirants of Gate 2023. Today I will be teaching you about types of pile, then load carrying capacity by static formula, then I'll tell you about pile grouping, then settlement of the pile group, and few of the numericals. Hello Ankur. Yes, good afternoon. Let us start with that. In a pile foundation, there are different type of pile, depending upon the type of material you are using, type of installation, there are a lot of different pile, but out of those, just I have taken few of them which you should know. Like, first of all, if the pile foundation depth by width, if it is greater than 15, we are calling it as pile foundation. So we are classifying it based on the end bearing pile and friction pile. You already know that a pile can take the load based on its end bearing and friction, that I will let you know. Then you have a fender pile. Fender, already you know that in a harbor and dock, to protect your dock, suppose this is your dock and the ship is going to hit, mass of the ship is too much, even if it is hitting it with a very small velocity, too much momentum. So to make this dock safe, we are using the fender. Fender is nothing but a kind of material which will be absorbing the impact. So here also we are providing pile. That pile we are calling it as fender pile. Then we have a anchor pile. Anchor pile is just for the tank purpose, which will be taking the tension, isn't it? You can imagine for maybe for bridges and all, for rope bridges, it's kind of nail inside the ground. If you'll just provide a pile, insert the pile, and if you're tying it here somehow and it's taking the load, this kind of pile we are calling it as anchorage pile, isn't it? At the bulkhead, and at the bulkhead we are actually providing that kind of pile. Then we have a batter pile. Batter pile is the inclined pile which will take the lateral loads, right? Sometimes you have a lateral load, like if you are providing the pile nearby retaining walls and all, lateral load is going to come over the pile. So near the retaining wall, suppose you have a retaining wall, and nearby that if you are providing the pile, so pile is going to take the lateral load. That lateral load, if you are having a pile, inclined pile, we are also providing, which is more capable. So that lateral load, if you have in your inclined pile, we are calling it as a batter pile. Then you have a Frankie pile. Based on the installation type, it is one of the pile in which, if you'll see at the base, you have a concrete bulb. It is different from the under rim pile. Whereas in under rim pile, you are providing the bulb at different position. It is at the base. We are providing just to compact the soil nearby the end area. The concrete we are providing, we are just pouring the concrete and we are hitting it, so that nearby the area of the soil will get compacted and the base of the end bearing will become comparatively better. That type of pile we are calling it as Frankie pile. Then you have a compaction pile. Sometimes you have a loose sand, and for the purpose of making it densified, you already know that as long as you are increasing you want to increase the shearing strength of the soil. So shear strength of the soil can be increased by compaction. The compaction will increase the density, and frequently, consequently the shear strength of the soil will get increased. So for that purpose, in the loose sand especially, if you are providing some short length of the pile for the compaction purpose, then we are calling this as compaction pile. And you also know that this, generally for the loose sand and all, if you are providing the pile, it can influence the compaction from its center. If you want to consider it from the center of the pile, at least thrice of the dia, it can influence that much of area for the compaction. And if it is for the soil, that is for kind of clay soil or cohesive soil, it will influence only twice of the dia. That's all. So we are just using it for more densified soil, so that our shear strength of the soil will become more, and more, load carrying capacity can be calculated. Now another one is sheet pile, which you have observed during the time of seepage and all beneath your dam and all. Due to the seepage of the water beneath the dam, you have a scoring of the soil. So scoring means the soil particles will get eroded, and to avoid that, if you are providing the sheet pile, what will happen if you are providing the sheet pile? Actually, it will increase the length of the flow, isn't it? Just beneath that dam, if you are providing that sheet pile, it will increase the length of the flow, and consequently the erosion will be stopped, isn't it? Erosion will be, less erosion will be there. So that sheet pile we are providing. These are the some of the pile which are very important. You should know. Sometimes they are asking for only 1 marks in the question. Okay, let us go for the another one. Load carrying capacity of a single pile. How a single pile is carrying the load. So static pile load formula, if you see, dynamic pile load formula, you have to calculate the load carrying capacity. Then you have a pile load test, and with the correlation of the penetration data also you can calculate that. We'll see today about the static pile load, how to calculate the load carrying capacity with the static formula, right? Now suppose you have a single pile. If you are having a pile and you have a load over to it, what will happen? Inside the soil, if you are just, if you have a pile, now due to the load, it will try to move down, isn't it? So from the base side, you will get some resistance, that we are calling it as end bearing or point bearing. From the base, you will get some resistance, that we are calling it as end bearing, and from the side of the skin, there will be friction, which we are calling it as a friction resistance, right? So one single pile will be carrying the total load only due to the end bearing and friction. That's all. So the load carrying capacity can be calculated very easily. The total load carrying capacity will be nothing but that load carrying capacity due to the friction. Load carrying capacity will be due to the friction, and load carrying capacity due to the end bearing, isn't it? That's all. Now next one, we'll see what will be the end bearing capacity of a single pile. Suppose you have a single pile. If you are applying the load, of course, from the base, you are getting end bearing. You remember already, we have already, studied in the shallow foundation when I told you that load carrying capacity. See, ultimate load carrying capacity, of course, once I will calculate the end bearing, bearing capacity of the soil at the base, that will help me, isn't it? So bearing capacity of the soil, if you can calculate, you can multiply with the end bearing area, and that will provide you the load carrying capacity. So as I was saying, that in a shallow foundation, we have already studied for the strip footing and all, this load carrying capacity, ultimate bearing capacity of the soil can be calculated by this formula given by Terjagi. Now as you know, it is a very deep footing. So the NC value, we are adopting it from the skem tons, that will become 9 subsequently, and shape factor for other than that you don't have to take, because already for square and circular, skem tons has given NC value which can be adopted for more depth, which is 9. At the same time, the last 0.5 gamma B N gamma, that can be avoided, because this is very small, very small term, because dimension of the pile will be very less compared to gamma D, NQ and CNC. It is very small, so we are neglecting it, we are just ignoring it. So now this is the bearing capacity of soil beneath the pile. Now For a cohesive soil and for a cohesionless soil, what will be the ultimate bearing capacity? For a cohesive soil, the first C and C we can consider for ultimate bearing capacity, and for cohesionless soil, gamma sigma NQ, that is nothing but gamma D NQ. So it is once again similar from the Terzeghis formula which I told you on that day. Once you can remember this formula, you will be able to recognize or remember the formula for load carrying capacity of a single pile also. This is for the cohesive soil and this is for cohesionless soil, right? Now let us see, if you have a pile which is resisting all the load due to the friction, how frictional formula can be calculated. So ultimate load carrying capacity, if you want to calculate only due to the friction, multiply all the frictional strength which we are getting it here, frictional force multiplied with the surface area of your pile, the skin of skin of your surface area of pile. If you multiply with that frictional force, you will get the total load carrying capacity by the pile due to the friction, isn't it? Now for a cohesionless soil and cohesive soil, how you can calculate? As you know that for a cohesive soil you have only the cohesion which is at that moment will be present. So the total load carrying capacity will be nothing but alpha C into pi dl. Pi dl is nothing but the total surface area of the pile, isn't it? Pi dl you are multiplying with the C, that is cohesion of the soil, but here we are multiplying the C along with the adhesive factor. This adhesive factor, as you can understand, if you have a soil to soil, grain to grain, the contact is between soil to soil, then alpha will become simply 1, isn't it? Because it is a cohesion of soil. C is nothing but your cohesion of soil. But if you have a pile of a different material which is attached with the soil, the cohesive part between the soil and the another material will be comparatively less. So alpha will vary from value like 0.9, 0.7, 0.8, 0.6 like that. At the same time, you understand, if your soil is very soft, if you have a clay and which is very soft, then you can say that your alpha will tend to almost equals to 1. Soft soil will stick together very well. For very soft soil, you can say alpha is almost equals to 1, and for stiff clay and all, alpha will be less because the adhesive factor will become very less, isn't it? So only an adhesive factor we are multiplying. This will give you the total load carrying capacity due to the friction in a cohesive soil. If you have a cohesionless soil, for the cohesionless soil, the total load carrying capacity will be K sigma bar tan delta into pi dl. Now pi dl is once again the surface area of the pile. Once again, you should understand the frictional resistance, how pile will be generating. Due to the vertical soil mass, you will be having, suppose if I will consider one point here. At this point, if I'll ask you what is the vertical stress at this position, you will say this is gamma into D, isn't it? Gamma into D. What is the lateral stress here? You will say that is nothing but lateral coefficient K into gamma D, isn't it? K into gamma D. Gamma D is, I'm writing down that K into gamma D. Gamma D I'm writing down as sigma bar, that is effective stress now. Acha, now K into sigma, that is effective stress, that is your lateral force. Due to the lateral force, the frictional resistance will be generating. The coefficient of friction, if you can find out, that is nothing but tan delta between the soil and your pile. This is coefficient of friction as per your normal frictional formula, mu times normal. So this is your kind of mu, and normal is your K gamma D, which is now the force coming normal to your pile. Are you getting point? So the frictional formula already, frictional force, you are generating mu times normal, and mu is your tan delta between the pile and your soil, and K sigma bar is nothing but the lateral force which is coming over the pile, and hence you can calculate the total load carrying capacity by using this formula. Did you get that? Now one more thing you can ask me here, this Q load carrying capacity I cannot write down simply like that. Why? Because see, this K gamma D, whatever I am writing down here, will be varying from top to bottom, isn't it? It will be varying from top to bottom. See, I have just written down at some position, or maybe the average one. You can write down instead. It will be better if I write down this sigma bar is average one. Average. For just now, for the time being, I will write it down, because the sigma bar is nothing but gamma D, and you already know that gamma D will be varying from top to bottom. As you will go for the larger depth, the gamma D value will be increasing. So it will be linearly varying from top to bottom like this. Did you get that? That's all. So these formulas are very easy to remember and easy to implement. Now go for the ultimate load carrying capacity of a pile group. How you can calculate, what to do. See, once you have understood what is the load carrying capacity due to the single pile, the pile group is also kind of same. Instead of a single pile, yes, you are having a soil mass where you are inserting your piles. See, you just see that you have a soil mass and you are here. You are inserting the piles here. As you are inserting the piles, we are considering that the complete area or complete soil mass as a one group. This is one block here. So what, first of all, you calculate what is the single load carrying capacity by single pile. Load carrying capacity can be calculated always due to what is the due to single pile, multiply with the number of pile will give you the total load carrying capacity if you are having large space between the piles. But if you are grouping it together, of course the stress bulb will overlap and the load carrying capacity will get reduced. At that particular moment we are calculating not individually, we are calculating it for a complete block. And when you are considering the complete block, implement the same concept except few things. What is few thing? Now you consider this block as a single pile, right? And these are the surface area which will be interacting with the soil. Suppose if I am considering for the friction, what will be the load carrying capacity due to the pile group. So this total surface area from all around will be taken care of, and suppose whatever the load carrying capacity you have calculated due to the friction. Suppose if I consider for cohesive soil or cohesionless soil, whatever you can take. So here the total surface area only will get changed. Suppose if it is for cohesive soil, earlier I gave you just a formula for cohesive soil. Load carrying capacity due to the friction will be alpha C into the area of your pile. Here area you have to calculate accordingly. The surface area, right? The total surface area you need to calculate accordingly. And alpha C, understand one thing here, if you are inserting the pile and you are considering the complete group as a pile, then here your soil is interacting with the soil. Here no interaction between the soil to another material, so no need to take care of its alpha. This alpha you can take it as 1. Are you getting my point? So adhesive factor, extra adhesive factor you don't have to take here. That will become simply L1. That's all. And other whatever your formula you are using will be same as. And the efficiency can be calculated if you have a group of pile. As a group, how much load it is carrying, and individually if you will calculate how much pile is taking, how much load is carried by the pile multiplied with the number of pile, that will provide you the efficiency of group pile. Now you can understand the efficiency of group pile will be almost always less than 100%, right? It will be always less than 100 or less than 1. It will be always less than 1. In percentage, if you are talking about, it will be less than 100%, or in terms of factor you are talking, it will be less than 1. But there is one exception here. There is one exception here. What? See, if you have a loose sand, generally for the clay you can simply write it down. For general all type of soil, you can simply write it down. The efficiency will be always less than 1. But especially for the loose sand, there is a possibility that your efficiency may be greater than 1 also. How? See, if it is a very loose soil, loose sand, if you are inserting the pile, actually it is going to densify the soil at that particular region. Due to the densification, now the load carrying capacity will get increased. So that is the only situation in which you can say that even at that situation of a loose sand, your efficiency may go beyond 1. That is the only possibility, right? For loose sand, N value may be greater than 1 also. These are the few important points which you need to remember. Now go for the pile settlement. So settlement of pile, if you see, already whatever the formula I gave it to you, same formula we are going to use for the consolidation chapter. If you have gone through already, this is the settlement I gave you for the settlement, isn't it? In a consolidation chapter, same formula you can implement here. Well, only thing is that if you are inserting the pile for a general, this is you consider it as a normal clay. Throughout it you have a clay here, and for this clay, for this soil, just 2 by 3rd of the L, you consider the load which is going to come. Suppose this P is going to come, this load which is occurring at this particular position, you consider that it is acting at 2 by 3rd of L. So total load and the area at this particular location, total load and whatever the area you have at 2 by 3rd of the length of the pile, calculate the area here, divide by this area, and you will get the stress at this location. You will get the stress at this location. Right? And beneath that, consider whatever the concept you have studied for the consolidation, same concept you can implement. Suppose if you have a 1:2 kind of, one horizontal and 2 vertical is your slope for the distribution of your load, then calculate, and beneath that whatever your soil, or maybe completely if this is clay, you go for the central position of the clay, and for at the central position you calculate, due to the implementation of the load, that is increment of the load, how much settlement will be happening at this particular zone. I'll teach you with one of the example also how to calculate the settlement in a pile group. Although sometimes if you have a very stiff and hard stratum, this 2 by 3rd of L you no need to consider. If it is very hard stratum, then the whole load you can start from at the base, instead of, if your pile group is resting on very hard stratum, then the complete load you can consider it is distributing it from base of that pile. That's all. Right? Now we'll go for one of the example here. Same formula will apply and we'll try to solve this problem. Here you have a 3 by 3 of pile group, and he's asking what is the settlement of the pile group, right? So total depth he has given as 7 meter, the pile length of the pile is given as 5 meter, hence this portion is nothing but your 2 meter, isn't it? He's asking what is the settlement, how you can calculate the settlement. As I told you, remove 2 by 3rd of the zone, and beneath the 2 by 3rd go for the distribution of the load and calculate the settlement at the center. Calculate the settlement at the center. So just calculate the distances first of all, then the settlement formula which we have already gone through in consolidation, apply that settlement formula and you calculate the settlement at the center of the clay. So at this location, first of all, if I'll say what is the formula we have, that is delta H equals to C H divided by 1 plus E naught log of sigma 1 bar plus del sigma divided by sigma 1 bar. Now you will be wondering, CC and H value already they have given here, CC value they have given, then H value already known to us, right? You can calculate simply your H value here, and 1 plus E naught is also provided, that initial void ratio. Sigma 1 bar and del sigma you need to decide. One should understand, if you don't have a load here, only due to the soil at this particular zone, what was the initial before the load, what was the stress at this particular zone. So calculate the effective stress at this particular zone. If it is a saturated one, just calculate the effective stress here, and that will simply become sigma 1 bar will nothing but, first of all you need to calculate this distance also from here to here, what is the total length, just will calculate it, right? Then sigma 1 bar will become, suppose this is take something y, the sigma 1 bar will become, before the load what was the total stress at this effective stress at this location, this is nothing but 20 minus 10, the effective stress if you are going to calculate 20 minus 10 into that y, that's all. That will be your effective stress before the load. Then del sigma you can calculate. How you can calculate del sigma? The total load you are providing it here, and then what is the total stress at this particular zone, by what amount the stress is coming at this particular central position. You calculate the del sigma for that and simply put it here, and you can calculate the settlement at the center of your clay. Let us do this one. So 500 kilonewton is acting here, 5 meter is your length of the pile, 7 meters. So at 2 by 3rd, just to calculate what will be the distance, this will be your 1 by 3rd of L, and this will be your 2 by 3rd of L, isn't it? This will be your 1/3 of L, and this will be your 2/3 of L. So 2/3 of L, if I'll say this is 2 meters, so total this length will become 2 plus, this is 2 already, 2 plus 2/3, sorry, 1/3 of your 5, which will be about 1.67, so it will be 3.67 meter. For this 3.67 meter, we are going to calculate the effective stress at the center of that, which is at 1.83, isn't it? Which is at 1.83. Now consider the point here. This height will become 1.83. Right? Already they have given the dia of the pile, that is 200 mm. Dia of the pile they have given, that is 200 mm. And center to center spacing is 0.5 meters. So the width will become 0.5 plus 0.51, and half of that from here 100 mm plus 100 mm, that is 0.1, and the width will become 1.2. So 1.2 by 1.2 is your dimension of your pile group, isn't it? Dimension of your pile group, I'll write it down, that B will become now 0.5 into 2 plus 0.2, which is 1.2. We are also interested in this particular length. This is Y, suppose this length, which I just wrote it down Y. So this Y will become how much? 7 minus 1.3. This is also 1.3. So 7 minus 1.3 will become Y. How much you'll get? 5.17. 5.17 meter. Now calculate what is your sigma bar. Your sigma bar here will become simply, first of all, that is the initial sigma bar before the load. The effective stress at this particular location will be sigma bar before the load. Your effective stress at this point P will be 20 minus 10 multiplied by 5.17. The depth here is now at point P is at a depth of 5.17 from the surface of the ground, which will become 51.7. I'm sorry, this is now 51.7. Easy now. 51.7, right, kilonewton per meter square. Then you calculate what is the del sigma, and to calculate the del sigma, how you can calculate del sigma due to the load of 500 kilonewtons. First of all, what is the width here at this zone? What is the total? We are increasing the stress at this location, so the area must be calculated here. This is the first term, so calculate what is the width. This is 1.2 plus half from this side, just with the slope 1:2. If you take the slope, if you take the 1:2 slope, calculate this green width. This width will become 1.83. This width will become 1.83, isn't it? This total width will become 1.83. No, 1.83. Sorry. 1.83 plus 1.2. This is already 1.2, and half from here, half from here. So it will become, this is already 1.2 now. We have just now calculated. This is already 1.2. If you take from here at 1.3, so half of 1.83 will be here, half of 1.83 will be here. So total will become 1.2 plus 1.83. So the point which you have considered here at that particular place, the area where the load will be distributed, this area will be 1.2 plus 1.83, and the total area will become, I can write it down, area at that particular place will become square of this. That's all. And this area, if you calculate, you will get around 9.1809 meter square. Now how you can calculate del sigma? Very simple. Del sigma, now by what amount you are increasing the stress at that particular location, due to your load only it is coming, no? So del sigma simply will become total load divided by that area, that is 9.1809. so it will become, how much you are getting? I think it will be around 54.6. 500 divided by 9.1809, 54.46. Now simply implement your settlement formula, which is delta H equals to Cc H naught by 1 plus E naught. I'll write down the value directly. Now total thickness here you have 3.67, H naught, that is 3.67. Cc they have given 0.027, see here 0.027, divided by 1 plus E naught, which is 1 plus 1.05, multiplied by log of 10. Earlier, before loading, before 500 kilonewton load, you are having the effective stress, that is 51.7. Now after application of the load, you are increasing the stress with the amount of 54.46. that is the increment you are providing due to the load. So 51.7, isn't it? Just to calculate how much you are getting, 51.7 plus 54.46 divided by 51.7 log base 10 multiplied with 3.67. Can you just tell me how much you are getting? Around 15. I think there is some calculation mistake, maybe if you have done, I don't know. Around 15 is coming. 15 mm. It will be coming in meter only, getting 0.015 meter. So around 15 mm you are getting. That's all. That is how you need to calculate the settlement for the pile group. That is very similar to what you have done in your consolidation. The settlement of your foundation in your consolidation, whatever you have studied. Now why you will take gamma D? Why you will take gamma D? Effective stress means you need to take the effective one, that's all. Can you calculate once again? Or maybe this value you can calculate. Or maybe there is some small mistake here. I was just calculating, I got 14 mm before the, around 15 mm. If you have any doubt, please tell me. Then we'll see a few of the other questions, like resistance load due to the skin friction for a circular pile varies with. For a circular pile, how it is varying? The skin friction for a circular pile, how much it is? Simply you need to write down the formula and you will get the answer. From the skin friction, how you are the load carrying capacity due to the skin. This is nothing but mu times normal is your total frictional force multiplied with your total surface area. So surface area of your, if you have a circular pile, the surface area will be pi dl, which will be multiplied with mu times normal. And normal, you already know that on a pile, your normal force is nothing but your K sigma bar, that is nothing but gamma D, isn't it? K sigma bar is your lateral. So mu times normal, this is your normal, and mu is already your tan delta. So I can write it down. This K sigma bar is nothing but K gamma D and multiplied with tan delta, that is mu times normal, into pi dl is the total surface area that will provide you the total load carrying capacity due to the friction. So how the resistance load due to the skin friction for a circular pile varies with, how it is varying now? It is varying with LD square, isn't it? So most appropriate answer, of course, it is varying with L also and with the D square also. Oh, sorry. I'm really sorry for that. Here they have, I just forgot to mention, this is your depth. This is your depth. And this dia, this dia is your, this is your dia. If it is your dia, then it is varying with the LD. It is varying with the LD. This small d is your dia. If I'm considering it dia, then it is varying with LD. If I'm considering with depth and length, of course, then also it is LD. If I'm considering it at a depth, I just forgot to mention. This D is nothing but your depth, na? Depth of the pile. This D, gamma, sigma bar, effectively will become gamma D, that is depth. Please let me know if you have any confusion. Now, group efficiency of the friction pile in a clay. As I told you, in a clay, it will be always less than 100%. That's all. It will be always less than 100%. Only for the loose sand, there is a chance, because it will get compacted, and there is a chance that the efficiency of the group pile may become more than 100%. Which of the following statement is not correct here? The adhesive factor for a load carrying capacity of group of pile is 1. This is absolutely correct. Because in a group of pile, when you are calculating, the soil is interacting with the soil during the time of friction. If you are considering for the single pile, the material of a pile is actually in the interaction with the soil, hence that is why the adhesive factor will become less than 1. So providing the sand drain will increase the settlement of the pile. Providing the sand drain will increase the settlement of the pile. See, he is actually asking about the amount of settlement. You know that from the consultation chapter only. If you provide more and more drainage, it is not going to increase your settlement. It is going to increase the rate of the settlement, isn't it? The time required for the total ultimate settlement will be smaller. If you are having more and more drainage, means water can dissipate very easily, and the settlement of the soil will be quite fast. But the total amount, the ultimate settlement, they are not going to increase. So this is the wrong one. So for this particular question, he is asking which one is the wrong. This is the wrong. This will be the answer. This is wrong. All other are all correct. This is also correct. Fender pile is used for the harbor. This is also correct. Minimum spacing between the pile group is, this is also correct. A square pile of section 30 by 30 and length of 10 meter penetrates a deposit of clay having C equals to 5 kilonewton per meter square and a mobilizing factor alpha 0.8. What is the load carried by the pile due to friction only? How you can calculate it? If it is a square pile, the load carried on a deposit of clay, that is on cohesive soil. So it is simple, alpha C multiplied by area. Now if it is a square pile, the surface area 30 by 30 is your dimension of the pile, and it is at a depth of 10 meter. So one surface area will be 30, that is 0.3 meter into 10. So 0.3 into 10 is one surface area multiplied with the 4. The total surface area. Alpha is given, C also is known here. Simply if you will calculate, this is 0.8 multiplied by 5 into 0.3 into 10 into 4. How much you will get? 8 by 40. 48 kilonewton, isn't it? When you have a soil, when you have a pile inside the sand, then you need to take care about the arching action of the sand. And due to that, generally for the loose sand, the critical depth we are considering as 15 times of dia. Means beyond that, Beyond that depth, see, in your sand, if I write down what is the total load carrying capacity due to the friction only, that is nothing but, as I told you, mu times normal, isn't it? So K sigma bar, and sigma bar is gamma d. I'll write down completely. That is gamma d, that is depth. Now K gamma d into tan delta multiplied by area, surface area. Now as you can observe, as long as you are increasing the depth, you are getting more and more load carrying capacity, but generally it is not going to happen. Why? In your sand, actually you have an arching action after some depth, and due to that particular reason, the depth has been restricted after that particular depth. That is, in a loose sand, generally it is considered for 15 times of d, and for dense sand it is considering as 20 times of d. Beyond that, your gamma d is going to be constant. Suppose this is your surface of your ground, and if you are inserting a pile here, then at 15 times, so in this is loose sand, just to consider it as a loose sand, the stress, that is gamma d, is continuously increasing. It is not going to increase for the total complete depth. After this critical depth, that is nothing but 15 times of dia of your pile. This is not depth, this is dia of your pile. After 15 times of dia of the pile, your stress is going to become constant. Then at that particular time, if you are interested to calculate what is the load carrying capacity due to friction only, first of all, for any of the pile, you find it out what is the critical depth. This is for loose sand. D is your dia of pile. And the load carrying capacity simply can be calculated. See, the stress is varying from 0 to gamma d here, and gamma d become constant. You calculate it in a two different stages. Consider the average stress here, and for this average stress, multiply with the total surface area till this portion. The first surface area here, divide it in two different zones. Area 1, the surface area 1, right? Total gamma d, this is the stress here. Then tan delta, of course, tan delta K gamma d, tan delta, and area 1. And along with that you add another one. Here the gamma d will become constant throughout, right? So simply gamma d you have to consider for this, and area also for that one. Same, K into tan delta, then gamma d into area of 2. This will be the procedure to calculate the load carrying capacity inside the sand due to the friction. This is not there for the clay. The arching action is only for the sand. So do not forget to consider the arching effect for the sand if you are going to calculate the load carrying capacity due to the friction. That's all for the day, and tomorrow I will be taking class at 3 p.m. for geometric design of railway. Thank you all of you. Have a nice day.